And of course, I thought of one more thing after I was like, oh, I'm done. No, we need to go back and talk about this. Couple of things, relative min and relative max. And the word that I'm going to use probably more often is turning points. So just a reminder, I'm looking at this polynomial right here, and I know it's a polynomial because all of my exponents are positive numbers. All of my coefficients are real numbers. It's also in descending order. I've got an x cubed, x squared, x. You could think of that as x to the 0. So this is what we call a third degree polynomial. We could also call it, since it's a third degree polynomial, we could also call it a cubic polynomial. It's an odd power. The degree of the polynomial is a third degree polynomial. 3 is an odd number. So that tells me that my end behavior is going to be different. Because it's a positive, that means it's going to be going up to the right, down to the left. Now, all of that information I got just from looking. It's what I call look and know information. A third degree polynomial can have at most 3 x-intercepts. It doesn't have to have 3, but it cannot have more than 3. And it can have at most 2 turning points. It doesn't have to have 2 turning points, but that's the most that it can have is 2. The n in this problem is 3. So the number of zeros is equal to n. The number of turning points is equal to n minus 1. So at most 3 x-intercepts and at most 2 turning points. Okay, so we're going to go to what? Graphing calculator. I think I have that open somewhere. Let's see. I'm trying to find my graphing calculator. I'm gonna get all of this down. Oh, it was this one. I couldn't remember what the thing looked like. And let's see, what was the, let me see if I can make this smaller. I'm trying to make this smaller so I can do them at the same time. So this is I need to go to a graphs page. And I'm going to do 2x raised to the third power, 2x raised to the third power minus 5x squared, minus 5x squared. Uh-oh, that's all wrong. You see how it's still up in the exponent? So I need to, there we go, minus 5x squared. You can do this on Desmos as well. If you don't have one of these calculators at home, which I know a lot of you don't, you can also do this on Desmos. I just wanted to show you what it looks like on the graphing calculator because when you're here at school and taking a test, that's probably what you're going to do. Minus 5x squared minus 4x plus 12. Minus 4x plus 12. Okay, I have no idea if it's going to graph enable for me to see it all. It looks like I need to be able to go up just a little bit higher. Hopefully, remember that's menu. Let's look at the window. I want to go to my window settings. I need a little bit more y-axis. So I don't know. I'm going to type in 20 and see what happens. Okay, so I can see my end behavior right here. This end is going on the right-hand side, it's going up. On the left-hand side, it's going down. And I can see 1, 2. We actually count this as 2 x-intercepts with the multiplicity. Well, again, that's a lesson for another day. But if right now, if you just counted 2 x-intercepts, that would be okay because we said it could have at most 3. So it has 2 x-intercepts. It has at most 2 turning points, okay? So it had those. Now, what your textbook wants you to do is understand that since this goes up forever, there is no absolute maximum value. The absolute maximum value is going to be infinity because it goes up forever. However, this turning point right here is what we call a relative maximum. And so you can use the calculator here. We're going to analyze the graph and we're going to find a maximum. It's not the absolute maximum, but it's a relative maximum. And we found it right there. It looks like it's at 1/3 and 12.7, or negative 1/3, sorry. Negative 1/3 and 12.7. We can also find this value right here, which is what we call a relative minimum. It cannot be an absolute minimum because this graph over here, the y values over here are smaller than that y value right there. But that is the smallest point for that part of the graph, and so that's why we call it a relative minimum. And again, you would analyze the graph, find a minimum value, and you would do it between here and here. And they show you right there that it is the relative minimum. So the relative maximum value right there, the highest point right there is 12.7. The relative minimum right there is 0. Again, you could do the same thing on Desmos. You would just have to type in the function and you'd be able to see, just point to it. Oh gosh, I don't remember what the function was now. 2x cubed minus 5x squared. 2x cubed minus 5x squared minus 4x and 12. Okay, so I think if you just point to it right there, it shows you the minimum value is 20, so the relative minimum right there is 2. Scroll your graph paper down a little bit, or you could go to the settings and fix your window right there. I think we did it to 20. Okay, so that's how we did. And then that one right there, after finding the other one was 12.7 on the graphing calculator, we know that that's the correct value. So you can do this on Desmos. If I ask you to graph, and I think I do on a couple of your assignments, let's see what your assignment is. I do have your assignment written down somewhere right here. It is on page 336, which I believe is this page right here, page 336. You are to do number 25, which says sketch the graph. Please do it on graph paper. Use Desmos or graphing calculator to get a few points. Turning points would be good. X-intercepts would be good. Y-intercept would be good. Then, because right here it asks you to name the x-intercepts, the y-intercepts, any relative maximums and relative minimums for that one. So those points right there will help you graph it. You can graph it on the piece of graph paper right here, but remember you are using some sort of graphing function, graphing calculator to help you do that, whether it's Desmos or the graphing calculator or some other app that you have. I want it sketched though. Please don't just copy it off of Desmos. I want to see that you take the time to sketch it and scale your graph paper the correct way and all that kind of stuff. Number 27 also asks you to make a sketch. Okay, sketch a graph. Now, when they say sketch a graph, I want you to actually graph it. They give you some ordered pairs. You should be able to get some other ordered pairs and some other things about them. There will be some things that won't have to be exactly perfect, but there are some things that will have to be, like the location of those points. And then do 28, 29. So here is your homework, numbers 25 through 29 on page 236, and you also have a 10 question, it says it's a test. It's not a test. It's just a homework assignment that is on It's Learning. So all of that is to show your understanding of this lesson. Okay, best of luck to you.